Morning students. In today's class we are going to study about a new chapter, data structure. The knowledge of data structure is essential to a person who design or develop the computer programs of any kind, either system software or application software. As data is the most important, it is very much required to access the group of relevant data. It is not so easy to handle the data if the volume is so high. So data has to be organized and stored systematically to perform the operations of them efficiently. Thus, there is a need of data types and data structures. So data structure is an organized collection of data to perform the required operations and to generate the desired results. So we need a data structure. So data representation. The different secondary storage devices are used for permanent storage of data. The commonly used devices are hard disks, compact disks, pen drives and so on. The block of data must be transferred from secondary storage to main memory. Later it is processed by the processor. So the data has to be organized and stored properly, and these data are used to perform the required operations and to generate the desired results. So there are different types of data structure. First you should know the meaning of data. Data is a defined collection of raw facts, figures or statistics. And information, it is a processed data which have a definite meaning. So data means it's raw facts. It can be a number, it can be an image, or it can be audio, video, anything raw facts it is. It does not have a meaning. But information, it is a processed data which have a definite meaning. So what is data structure? It is a specialized format for organizing and storing data. So you have a format how to store the data, it has been organized in some way. It is a specialized format. You have a format for organizing and storing data. That is the meaning of data structure. It is a method of storing data in memory so that it can be used efficiently. So we are storing this data in the memory and later you can use this data efficiently. So this is known as data structure. So you are having a specialized format for organizing and storing data. Classification of data structure. The data structure is classified into two types, that is primitive data structure and non-primitive data structure. Under primitive data structure we have got integer, floating point, character, pointers. Okay, we have studied about the primitive data structure, that is integer, floating point, char and pointers. Also we studied this year. A non-primitive data structure, it consists of arrays. Under arrays you have different types of arrays, that is single dimensional, two dimensional and multi-dimensional. And under non-primitive data structure, again you have the classification of data structure, list and file. Under list you have got two types, that is linear data structure, non-linear data structure. Under linear data structure you have got stack, queue, linked list. Under non-linear data structure we have got trees and graphs, and files is the last non-primitive data structure. So in this chapter we will be studying about the data structure, that is primitive as well as non-primitive data structure, the operations that are performed on primitive data structure, non-primitive data structure, and what is an array. Already we know what is an array in our previous classes, that is last year we have studied about arrays. And list is a new thing what you are going to learn, and linear and non-linear, what is difference between these two, and what is a stack, queue, linked list, and what is a tree, graph. All these concepts we are going to study in this chapter, that is data structure. So under data structure is classified into primitive data structure and non-primitive data structure. That is the main classification of data structure. So data structure that are directly operated by the machine level instructions are known as primitive data structure. So that is, it is already available in the computer. So there are the different primitive data structure like int, float, char, pointer, etc. So we have studied about the data types in your first year, that is int, float, char, all these are the data types. So pointer we studied this year. Pointer is a variable that will hold the address of another variable. Operations on primitive data structure. There are different operations on primitive data structure, that is create, destroy, select, update. These are the different operations on primitive data structure. So first let us see what is create. Create operation is used to create a new data structure. This operation will reserve memory space for the program elements. So example int x. So 2 bytes of memory will be allocated for x. So this operation mainly it is used to create new data structure. The next operation is destroy. This operation is used to remove the data structure from the memory space. So in order to remove the data structure which has been created, we are using destroy data structure. C++ allows the destructor member function to destroy the object. So we have studied about constructor and destructor. In that you have studied about destructor. So destructor is used to destroy the object. So we are using the operation destroy to remove the data structure from the memory space. The next operation is select. Select operation. This operation is used to access the data within data structure. So you have to access a data. Whatever 10 datas are there in a data structure, you have to access one by one. You can access. So you can select the data. So this operation is used to access the data within the data structure. The next operation is update. This operation is used to change data in the data structure. For example, x is equal to 2. Your x is assigned to 2. Now you are reassigning that x value as 5. Okay, previously you have assigned 2, but later you are updating that value to 5. It has been reassigned to 5. That is now the value of x is 5 and it is not 2. So that is called as update operation. So you are modifying the data which is there in the data structure. So these are the different operations on primitive data structure, that is create, destroy, select, update. These are the different operations on primitive data structure. This question can be asked for 5 marks. That is, they can ask you what is primitive data structure and write the operations on primitive data structure. And you know that data structure is being classified into 2 types. One is primitive data structure and the second one is non-primitive data structure. And you know what is a primitive data structure and the operations performed on primitive data structure. Let us see what is a non-primitive data structure. These are derived from primitive data structure. So primitive data structures are int, float, char, pointers. All these are the primitive data structure. These are data structure, that is non-primitive data structures are derived from the primitive data structure. So data structures that cannot be directly operated by a machine level instructions are known as non-primitive data structure. Example for that is array, list, files. All these are the example for non-primitive data structure. In simple words, we can tell the data structure which is derived from primitive data structure is called as non-primitive data structure. Data structures are classified into 2, that is primitive data structure and non-primitive data structure. You know the meaning of primitive data structure and non-primitive data structure. Under non-primitive data structure, you have got arrays, and under list you have got linear data structure and non-linear data structure. So what is linear data structure? Linear data structure are a kind of data structure that has homogeneous elements. All the elements are of same type. So then we call it as linear data structure. Features of linear data structure, that is it has homogeneous, all of same type elements. So that is a feature of linear data structure. Here the elements are arranged sequentially. Linear means sequentially, that is one after the other the elements are arranged, then we call it as linear data structure. They have linear relationship between data elements. So they have a relationship one after the another, the data is stored. So then it is a linear data structure. The examples for linear data structure is arrays, stack, queue, linked list. All these are linear data structure. There are some operations on linear data structure or non-primitive data structure. So different operations on linear data structure are traversal, insertion, deletion, searching, sorting, merging. So these are the different operations on linear data structure. The first one is traversal. The process of accessing each data item exactly once to perform some operation is called traversing. That is, you are moving from one element to the another element exactly once, then it is called as traversal. Traversal means accessing each data item. The next operation is insertion. The process of adding a new data item into a given collection of data items is called insertion. So So you're inserting an element, already you have 10 elements, you want to insert another item, that is data item, into the 10, that is the, you have a group of elements, you're going to insert one more item over there, then we call it as insertion as the 11th item. Okay, 10 data items you have got, now you have to insert the element at the end or at the beginning, or it can be in the middle. So somewhere you are inserting the element. So the process of adding a new data item into a given collection of data item is called as insertion. Okay, so the next one is deletion. The process of removing an existing data item from the given collection of data items is called as deletion. So there are 10 elements, and one element you want to delete at the end or at the beginning. You want to delete an element from the existing collection of data items, then it is called as deletion. Searching. The process of finding the location of the data item from the collection of data items is called searching. So there are 100 data elements. So you want to find out whether one data item is present in that data items, that is 100 data items. Then we start searching one by one whether that element is found or not. So the process of finding out the location where that particular data item is placed, which location it is placed, is called as searching. Okay, the process of finding the location of the data item from the collection of data items is called as searching. You are searching whether that element is found or not. If the element is found, it is success that the element is found. Otherwise, it is not found. So this is what searching means. The other operation on linear data structure is sorting. The process of arranging the data items in ascending or descending order. So the elements are there, it is not arranged in proper order. Okay, so you are arranging it in a proper order. So for example, if we take the names of the student, if the students are not arranged, the first the name of for the student starting with Z is there, next G is there, next W is there, so it's not arranged properly. So we start arranging, that is first we start with A, then B, then C. So it is an arrangement is being done. Then it is called as sorting. The process of arranging the data items in ascending or descending order is called as sorting. It not only consists of the characters or the string values, that is collection of characters, it can be numbers also. The numbers also can be arranged in ascending or descending order. The last operation is merging. The process of combining the data items of two data structure to form a single data structure is called merging. So there is one data structure A and there is one more data structure B. So now you are merging the two data structure into a single data structure, then it is called as merging. So these are the different operations on linear data structure, or they can ask the same question as non-primitive data structure. So what are the operations which can be done? Traversal, insertion, deletion, searching, sorting, merging. So these are the different operations that can be done on linear data structure or non-primitive data structure. This question, that is operations on linear data structure or operations on non-primitive data structure, can be asked for 5 marks. So you have to mention the 5 operations. We have given 6 operations. Any 5 operations you can mention and write the meaning of these operations for 5 marks. It is one of the important questions for final exam. The next topic is nonlinear data structure. Now we studied about the linear data structure. Now the other one is nonlinear data structure. So we have two data structure, that is primitive and non-primitive. Under non-primitive we have nonlinear data structure. A nonlinear data structure is a data structure in which a data item is connected to several other data items. So one data item will be connected to the another data item. In that case we tell it as nonlinear data structure. So there are 2 or 3 data structures. So one data structure will be connected to another data structure. Okay, so it need not be in a sequential way how it was in linear data structure. It was in a sequential way, that is one after the another the data items were connected. But in this case there is nothing like that. The arrangement of the elements need not be sequentially. So let us see in the features of data structure, that is nonlinear data structure. The data elements are not arranged sequentially. What do you mean by sequentially? not in a linear way, not one after the another. Okay. Every data elements are attached to several other data items. So only we told it is connected. So one data item will be connected to another data item. Element and data item both are same. Data elements and data items both are same. So every data elements are attached to several other data elements. So the example for nonlinear data structure is trees and graphs. We will be studying about the nonlinear data structure again. So we will be explaining what is a tree, what is a graph, then you will understand what is it. It will be a diagrammatic representation, the tree and the graphs. So you will come to know that the data is not it is connected, but it is not arranged sequentially. So this is the meaning of nonlinear data structure. Nonlinear data structure means a data structure in which data item is connected to several other data items. Then it is called as nonlinear data structure. Okay. Let us have a recap of what we have studied today. What is data structure? Data structure is a specialized format for organizing and storing data. It is a method of storing data in memory so that it can be used efficiently. So data structure means it's a format for organizing and storing data so that it can be used later efficiently. Classification of data structure. In this you have two data structure, that is primitive data structure and non-primitive data structure. Under primitive data structure you have integer, floating point, character, pointers. Under non-primitive data structure you have got arrays. Under arrays you have got single dimensional array, two dimensional array and multi-dimensional array. Under non-primitive you have got list and files. Again under list you have got linear and non-linear. Under linear you have got stack, queue, linked list. Under non-linear you have got trees and graphs. So let us see what is primitive data structure and non-primitive data structure. So primitive data structure means a data structure that is directly operated upon the machine level instructions are called primitive data structure. So there are different types of primitive data structure like integer, floating point, character, pointer. All these are the examples for primitive data structure. But what is non-primitive data structure? Non-primitive data structure is a data structure which is derived from primitive data structure. So different examples are there for non-primitive data structure, that is arrays, stack, queue, linked list, trees, graph. All these are the examples for non-primitive data structure. The different operations on primitive data structure are create, destroy, select, update. Create operation. Create operation is used to create a new data structure. Destroy is used to destroy or to remove a data structure. Select is used by the programmers to access the data within the data structure. Update operation is used to change the data in the data structure. So these are the different operations on primitive data structure. Let us see the operations of non-primitive data structure or linear data structure. So non-primitive data structure, okay, which is derived from the primitive data structure, there are some operations that can be done on non-primitive data structure or linear data structure. They are traversal, insertion, deletion, searching, sorting, merging. So these are the different operations that can be done. Traversal means the process of accessing each data item exactly once. Insertion means the process of adding a new data item is called as insertion. Deletion means deleting an element from the data structure. The next is searching. Searching means finding the location of the element in the data structure. Sorting means we are arranging the data in ascending or descending order. Merging two data structures are there. We can merge these two data structure into a single data structure. These are the different operations that can be performed on non-primitive data structure. There are two types of data structure. One is primitive and the other one is non-primitive. Under non-primitive data structure you can see arrays, list, files. Arrays, it has been classified into one-dimensional, two-dimensional, multi-dimensional. And list is being classified into linear and non-linear. Under linear you have got stack, queue, linked list. Under nonlinear, you will be having trees and graph. So what is this nonlinear data structure? It is a data structure in which data item is connected to several other data items. So one data item will be connected to another data item, then we call it as nonlinear data structure. So example for nonlinear data structure is trees and graphs. They might ask you, give the example for nonlinear data structure. Then trees and graphs are the example for nonlinear data structure. Or they might ask you, what is nonlinear data structure? So there are different questions that can be expected from this chapter.